So for this graph here, we know if you take a look at page 266, example 5, it's that's a very good one to look at. So I'm seeing a log graph that still has an absolute, has a vertical intercept, a vertical asymptote of 1 instead of 0. So that tells me it's been shifted to right 1. I'm also noticing that typically the log graphs look like this coming up, and this has been reflected around the x-axis, so that tells me the A is going to be negative, though we don't have to worry about that yet. Then I know these points, and I can find another point too to help me along the way here. So I'm going to include that shifted right 1 right there. So we know it's A log of x minus 1 plus k. And let's see, I see this 0.22. Why don't we substitute that in and see if we can't use that. So I know 2 has to equal a times the log of, 2 minus 1 is 1, plus k. Well, the log of 1 is 0, so that knocks that whole term out, so that tells me k is 2. So it's been shifted up 2 units. So a times the log of x minus 1 plus 2. And then I see this other point, 0. I can substitute that in for some things here. So 0 has to equal a times the log of 3 plus 2. 3 came from 4 minus 1. So I'm going to subtract 2. Then I'm going to divide by the log of 3. And that should be what a is. So what I'm seeing and I'm thinking, I've got a function that's defined by negative 2 over log 3 times the log of x minus 1 plus 2.